Swayam Prabha. Digital India. Educated India.
Welcome everyone, and I am Dr. Sarthak Sarkar, an Associate Professor in Applied Mathematics in IIT Delhi. And in this new course, I will be talking on classical mechanics using variational calculus. The motivation to initiate this course comes from the fact that we have two separate branches of classical physics and applied mathematics, and this particular course is a way or an incentive to amalgamate or coalesce both these so-called diverging topics into a single unified one, and to motivate the students in both these disciplines. So, using variational calculus, the major theme of this course is on the study of the various conservation principles. That is applied to the topics of including vector mechanics as well as the analytical mechanics, especially where these principles are shown to be related to the so-called Lagrangian. Now, some of the other key points in this course are that roughly 30 to 40% of the initial content is reasonably simplified, so that students, especially in the undergraduate division of physics and mathematics, can easily follow. And then what I expect is only a basic background in ordinary calculus in order to go through the various topics of this course. Then we have lots of worked out examples, solved examples throughout the various lectures of the course. And also I want to highlight that although most of the problems are theoretical in nature, but I will be introducing few problems which will demand computational simulations, especially for example, we will see in the topics of, for example, the case of limit cycle. Then we have given as the name suggests, we will be dealing a lot of examples using variational calculus. So a careful treatment of variational principles and the concept of Lagrangian is emphasized in this course. And then we also introduce a very gentle, very moderate level of tensor algebra in order to cover some of the advanced topics, especially in rigid body mechanics, towards the end of this course. Now, some of the classic and the good books to follow for the students are those with the same name, that is Classical Mechanics by, for example, Herbert Goldstein or Daniel Kleppner or R. Gregory. So this is in a nutshell what we are going to cover in this course. And to give you a bit more detail on this topic, let us now talk about the step by step or the week by week discussion of the various topics that I will be covering. So in the first week, I will be covering topics on the basics of calculus. For example, vector calculus, ordinary linear algebra, and some of the fundamental theorems of linear algebra, and so on. And then I straight away go to the development of Newtonian mechanics, the concept of velocity, angular acceleration, and then talk about some, of course, when we talk about these topics, not to mention that each of these topics will be followed with lots and lots of worked out examples. And then we straight away then after that go to some famous laws, for example, the laws of gravitation, the Newton's laws, and the introduction of the acceleration due to gravity. So then we go to we go to the description of single particle dynamics. That will involve the motion of a single particle in a rectilinear path, or as well as in circular paths. And then we are going to talk about the theory of linear oscillations. That will include the classic study of simple harmonic motion, including the classical harmonic motion, the damped harmonic motion, and so on. Then we also we are going to then spend a significant amount of time in energy, the energy laws, the energy conservation. For example, we will talk about energy conservation in various types of motion like rectilinear or circular motion, and then we talk about the various types of also we will talk about the energy conservation in constrained motion as well, for example. So that is something we specifically include. And then after this discussion of the various linear conservation laws, we will talk about the various application of these conservation principles. For example, a classic example is that of the orbital motion. For example, how the various orbits are following the conservation of energy and the conservation of course, the momentum in order to go about in a way that we all know. So then we talk, after that we start to introduce problems involving non-linearity, starting with non-linear oscillations and phase space. We talk about, from here we talk about some concepts in dynamical systems, especially the topics that we will be interested in this course will be on the case of limit cycles, as well as the so-called Poincare-Bendixson theorem. And then, so just to emphasize why we are interested in these topics is because they are going to be the precursor to the development of our Newtonian mechanics through variational calculus. So then we also spend some time on multi-body systems. We revisit some of the topics, including the linear conservation and the linear momentum conservation and the energy conservation for multi-bodies, starting with two particle systems. And then we introduce, along the way we introduce some applications. For example, we talk about the Newtonian aerodynamic problem, or the motion of the rockets and bullets. We also talk about the so-called scattering theory, or the so-called collision theory, where we have the famous, which also will include the famous Rutherford's experiment for the scattering of neutrons. And then we will then introduce our conservation of angular momentum for multi-body system. And then so that half of this course will be complete, which will be mainly on the discussion of the classical topics of classical physics. And then we will start with, after that we will start with our the methods of variational calculus, starting with the derivation, or starting with the first introduction of the so-called Lagrangian, or the concept of work, the concept of energy in mathematical language, and then the introduction of Lagrangian. So then following this, we will introduce the so-called Euler-Lagrange equation, which forms the basis of the variational calculus. And we are going to use this Euler-Lagrange equation to, not only this, we will also revisit this Euler-Lagrange equation in another form, the so-called Hamilton's principle. So we use this form of Euler-Lagrange equation, or the so-called Hamilton's equation, again in the various conservation laws, and we will see that eventually these conservation laws, they arise out of the so-called certain symmetries of the system of particles. the notion of symmetries will also be introduced, and finally the end result of all this discussion will be the culmination of the so-called Noether's theorem. The Noether's theorem is a very beautiful result of the application of symmetries when applied using the variational principle. Then we will start introducing a very mild we will start with a very mild introduction of tensor algebra, with a goal to introduce the so-called rigid body mechanics in two dimensions as well as 3 dimensions. We will talk about body statics, body rotating as well as rigid bodies, and then we are going to touch upon some advanced topics in classical mechanics and try to solve them using with or without variational calculus. For example, the motion of the so-called gyroscope, or the motion of a spinning top. These are some of the more complicated motions which we will see later on towards the end of this course. Almost all, of course, all but one topic will be introduced primarily through worked examples. The one topic where we will introduce some theorems and proofs will be in the introduction of Lagrangian, that is when we introduce the Euler-Lagrange equation. So I hope that the students will be, especially in almost all disciplines of engineering, mechanics, physics and mathematics, will all be interested to see the various worked out examples in this course, and will enjoy these various topics in this course. So thank you very much, and I hope to see all of you from starting from lecture 1. Thank you.